Okay, welcome to chapter 2.4, modeling with quadratic functions. The essential question of this chapter is how can you use a quadratic function to model a real life situation? What you will learn in this video is how to write equations of quadratic functions using the vertices, points, and x-intercepts. And you will write quadratic equations to model data sets. Okay, the core concept is writing quadratic equations given a point and the vertex, and they're going to call the point h comma k, x comma y. The point is going to come from the equation. H comma k is going to be the vertex from the vertex form of the equation. The vertex form of the equation is y equals a times the quantity x minus h squared plus k, where the number here is their x value opposite, because minus and h, if h is negative, it's minus and negative is plus, and if h is positive, minus a positive is negative. And k is going to be your y value of your vertex. Given a point and x-intercept p and q, so you're going to use intercept form, y equals a times x minus p times x minus q. And given 3 points, write and solve a system of 3 equations in 3 variables. Okay, example 1, writing an equation using a vertex and a point. So the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled by the cannon ball that's traveling in feet. Write an equation of the parabola. Actually, it's the performer, so it's a human cannonball. So how far did that person go? They get shot out of this cannon, they go up, they reach a maximum, which is the vertex, and then they come down, and then it says to write an equation of this parabola, and then the performer lands in a net 90 feet from the cannon. So here's 0, here's 80 feet from the cannon, and here is 90 feet from the cannon right here. And we want to know what the height of that point right here is. That's what they're asking. Okay. So we have this point here, we have this point here, and we have this point here. The question is asking us what the y value is here because we know this is 90. We want to know how far from here did the guy go before he landed on the net, and how, or actually we know he went 90 feet, but we don't know is how high the net is off the ground. And that's what we're going to find out. So we're going to start by writing the equation. Y equals a times x minus h quantity squared plus k. All right, so we have a y, we have an a, we have an x, we have an h, we have a k. We have no numbers in this equation at this moment, but we can find them. So we're going to use our starting point. So this is going to be our x, this is going to be our y, and the vertex is h comma k. So there's our x, there's our y, there's our h, there's our k, and when we substitute that in, we're going to have everything except a. But when you simplify an equation down to one variable, you can solve for that one variable. So y is 15. A we don't know. X is 0. Minus h, 50. Squared plus k, which is the y value. Oops, I said k when I was trying to write it, and I wrote k instead of 35. So k is the y value of our vertex h comma k. So here is the equation. Now let's solve for a. Leave 15 alone for now. Leave a here. 0 minus 50 is negative 50 squared plus 35. 15 equals a times negative 50 squared is 2,500, and it becomes positive. A negative times a negative is positive, plus 35. Subtract 35 from both sides, and I get negative 20 equals a times 2,500. To get a by itself, we're going to divide both sides by that 2,500. These cancel, and I get a. And this is going to be negative, and it comes out to be 0.008. I did it in the calculator already. Okay. So it's negative 20 divided by 2500, which is negative 0.008. And so there is our A. So now I can take that A and plug it into this equation again. But now we want to find out what y is when x is 90. So I'm going to write, now we have our equation, y equals negative 0.008 x minus h squared plus, I forgot my plus k. So y in this case is what we're trying to find. Negative 0.008. X is 90. Let me change that to red. X is 90. It's this 90 right here. The performer lands in the net 90 feet from the cannon. And x minus h, which is 50, squared plus 35. Okay. And then this just simplifies down. We're just going to get solve for y when x is 90. So it's negative 0.008 times 40 squared plus 35. Y equals negative 0.008. 4 times 4 is 16, plus those two zeros would be 1,600 plus 35. Y equals, and I'm going to multiply these now. Clear point negative 0.008 times 1600 is negative 12.8 plus 35. So y equals, well, 35, I'll just do it over here. 35 minus 12.8. I have to borrow from the ones, and I get a 2, and 4 minus 2 is 2, and 3 minus 2, so I get y is 22.2 feet. So that's how high the net is off the ground. And if we got an answer that was less than 15, we should question it, because this point is higher than this point, and this is at an elevation of 15 feet, and he landed up here at 22.2 feet. Okay. Okay. Example 2 is writing an equation using a point and X-intercepts. So a meteorologist creates a parabola to predict the temperature tomorrow, where X is the number of hours after midnight on the X-axis, and Y is the temperature in degrees Celsius. So here's the temperature, negative and positive. Write a function f that models the temperature over time, and what is the coldest temperature. So what they're asking for in this question is an equation for this parabola, and what is the coldest temperature, or the minimum, which is the vertex. Okay. All right, so what we're going to do is we're going to write the formula for the X. It's the intercept form, and it's y equals a times x minus p times x minus q. Right? And where are these letters coming from? Well, this is y, which is 9.6. X is 0. So there's my point, that the y-axis, we're using the y-intercept, 0, 9.6, x, y. This point right here, this 4 is p, and this 24 is q. P and q are your x values of your zeros, or your x-intercepts. So here's the equation, y equals a times x minus p times x minus q. And then we just substitute everything in and find a. So y is 9.6 equals a times and it's x minus p. Well, x is 0, so it's 0 minus p, which is 4, times the x again, which is 0, minus q, which is our x value of our other x-intercept, 0 minus 24. Okay, so simplify. 9.6 equals a times -4 times -24. So 9.6 equals a times negative times negative is positive. 4 times 4 is 16. Carry the 1. 4 times 2 is 8. Plus 1 is 9. And we get 96. To get a by itself, I'm going to divide by 96 on both sides. And these cancel, and we get a equals, well, anything divided by itself is 1, and we have one decimal place. So this is going to be 9.6 divided by 96 is 0.1. Okay, so remember what we're trying to do here. We're trying to find the vertex. And the vertex is always midway between the two x-intercepts. So we are looking for the value of x, that is a vertical line going through the vertex. And this would be x equals whatever value that is, okay? And how do you find it? Well, we have the point 40 and we have the point 24,0. So first I'm going to find the x value of my vertex. And in order to find that is you take each end and add them up and divide by 2, and that's your midpoint. So you're going to take 4 plus 24 divided by 2, which is 28 divided by 2, which is 14. So now I know that x equals 14 is my axis of symmetry, and therefore my vertex is the point 14 comma something. So 14 hours after midnight, which would be 2 p.m. the next day, was our coldest temperature. So now I know when it was, but we didn't answer the question yet. It said, what is the coldest temperature? So now I'm going to take my equation, y equals 0.1. This is my a, right? A is 0.1 times x minus p, x minus q. And instead of putting x in there, I now want to use this as my x. X is 14, so I'm going to erase those. And I don't want an x here. Well, let's just leave it for now and just write the formula and substitute our givens. Let's do it that way. So now it's y equals 0.1, and now I'm going to substitute in 14 for my x. In both places, and solve. 14 minus 4 is 10. 14 minus 24 is -10. So y equals 10 times -10 is -100, and 1/10 of a -100 is -10 degrees. So at 2 p.m., 14 hours after midnight, 12 hours after midnight would be 12 p.m. 2 more hours would be 2 p.m. It'd be -10 degrees Celsius. Part B says, what is the average rate of change in temperature over the interval which the temperature is decreasing, in which the temperature is decreasing, increasing, and compare the average rates of change. Okay, so the parabola is decreasing. I click on the red. Okay, the parabola is decreasing from here to here. Okay, we are going down on the y values until we get to the vertex. We get to the minimum, we turn, and we start going up. So I will use red for negative decrease and green for a positive increase. So those are our two areas in which we are decreasing and then increasing. And we want to find the average rate of change. Well, the average rate of change is your function value y minus y over x minus x. It's very similar to the slope intercept or the slope formula, m equals y2 minus y1 over x2 minus x1. In this case, it would be f of this value here, 14, minus f of this value here, 4, over 14x minus y4, or I'm sorry, x4. 14 is my x minus my other x4. This is just the left side. So f of 14 just means what is y when x is 14? Well, when x is 14, y was negative 10. And what was y when f was 4? Which is right here, when f was, and when x was 4, y is 0. So it's negative 10 minus 0 over 14 minus 4, which is 10. Negative 10 minus 0 is negative 10. Negative 10 divided by 10 is negative 1. So that is not right. Okay, I made a mistake, but I'm just going to fix it rather than start over. So I only went from here to here. It's actually decreasing. I didn't take into consideration about 0 hours from midnight. At midnight, it was 10 degrees. I did not take this into consideration. I want these values. So I just need to change a couple of things. It's f of 14 minus f of 0, not f of 4. So it's going to be f of 0. Okay, let me recap that. F of 14, x is 14, minus f of 0 right here. Okay, and that will not be 14 minus 4. At f of 14, it will be 14 minus 9.6. Actually, it is 14 minus 0. So f of 14 minus f of 0 over 14 minus 0. So when I do that, let me just erase all this. F of 14 is negative 10 minus f of 0, which is 10, over 14 minus 0. Negative 10 minus 10 is negative 20 over 14, and that reduces to negative 10 over 7. Okay, which is a decimal approximate, is negative 1.4. Approximately. Is that an approximation? 7 goes into 10 once, remainder of 3. 7 goes into 34 times 28, remainder of 2. Yeah, it keeps going, but we're rounding to 1 decimal place. Now we're going to do the same for the other side. So now we're going to take f of 14, now we're going all the way out to this point right here, which is 24. So it's f of 24 minus f of 14 over, and it's going to be 24 minus 14. Okay, the y value at 24 minus the y value at 14 minus the x value, or the x value divided by the x value minus the x value. So f of 24 is 0. F of 14 is minus a negative 10, which is plus 10, over 24 minus 14, which is 10. And I get 10 over 10, which is 1. Okay, so the temperature from midnight until 2 p.m. dropped on average 1.4 degrees per hour. It then, from 2 p.m. until midnight, it increased 1 degree per hour in Celsius. So the average rates of change look different, but actually the time is a different amount of time. We're taking 14 hours in a day, comparing it to the other side, which is only 10 hours. Okay, so there's the answer to part B. One last thing I can do with this is I can now draw that average rate of change. I'll use blue. And so all that is a straight line from the starting point to there. So this has a slope of negative 1.4. And then this would be a linear function, if you will, going up here. The average rate of change from 14 to 24 has a slope of 1. Okay, writing equations to model data. When data have equally spaced inputs, you can analyze patterns in the differences of the outputs to determine what type of function can be used to model the data. Okay, so let's look at that, what they just said. When data have equally spaced inputs, the input is X, this is input, equally spaced. Well, this is 1, plus 1, plus 1, plus 1, plus 1, and plus 1. Okay, those are equally spaced X's. Let's get that out of the way. So that's step 1. Is the input equally spaced? If so, you can continue. Then you look at the outputs and you take the difference. So you can analyze patterns in the difference of the outputs to determine what type of function can be used to model that data. Linear data have constant first differences. So the first difference is constant. Quadratic data have second differences. The first and second difference of f of x equals x squared are shown below. So this is the function x squared, negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, and so on. These are all just x squared. That's the parent function of a quadratic. Equally spaced x values, inputs, and the outputs. To get from 9 to 4, it's a difference of 5. We had to subtract 5. To get from 4 to 1, we had to subtract 3. Those are different. I automatically know after doing the first two that this is not a linear function because they'd all be the same in the first difference. Does that make sense? Okay, so we do that first. 1 minus 0, or 1 to 0 is negative 1. From 0 to get to 1, we had to add 1. 1 to 4 is 3, and from 4 to 9 is 5. So those are the first differences. Then you take the second difference, and to get from negative 5 to negative 3, you had to add 2. To get from negative 3 to negative 1, you had to add 2. Negative 1 to 1, add 2. 1 to 3, add 2. 3 to 5 is add 2. And we have a second difference where they're all equal. So now we know that this data is a quadratic function. Okay, so now let's take a look. Okay, example 3. Write a quadratic equation using 3 points. NASA can create a weightless environment by flying a plane in a parabolic paths. The table below shows the height h in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. So before we do that, it does say writing a quadratic equation here, but we have to confirm that it is a quadratic function. So I'm going to put my t times in here, 10, 15, 20, 25, 30, 35, 40. And then I'm going to ask myself, are all of these values a common difference? And it is. We have to add 5, add 5, add 5, add 5, add 5, add 5. So if I go back to this example, okay, the differences of the outputs, actually the first, where does it say? When data have equally spaced inputs. There it is. So I have equally spaced inputs of 5. And now we're going to do 26,900, 29,025, 30,600, 31,625, 32,100, 32,025, and 31,400. So notice something here. Increasing, 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 decreasing, decreasing. So right here, somewhere in between here and here, it went from increasing to decreasing. So it's doing this. Okay, so we now know it possibly is a parabola just by looking at that, but we still have to confirm. So 29,025, and let's just do it in our calculator so we don't make any mistakes. 29,025 minus 26,900 is 2,125. Okay, that is the first difference. Actually, I want to write it over here more, and I'll draw arrows down to it, showing you that it's the difference between those two. Now, what's the difference between these two? Okay, go back to my calculator. 30,600 minus 29,025 is 1,575. Okay, so now when I look at these first two, I notice they're different. So I know for a fact now it's not linear. Even though it was increasing then decreasing, this confirms that it's not a linear function because they weren't equal on the first difference. So now I'm going to take 31,625 minus 30,600. And I get 1,025. And then I take the difference between these two. And it's going to be 32,100 minus 31,625. And that comes out to be 475. Okay, and then 32,025 minus 32,100. And that's negative 75. And then finally, 31,400 minus 32,025. And that's negative 625. All right. Okay, so now we're going to take the second difference. Let's get the calculator out. And it's going to be 2125 minus 1575. Well, I don't need a calculator for that. 2125 minus 15, well, 2125, be careful, minus 1575 equals 550. 1575 minus 1025, that is also 550. Subtract 550 from 1025 and you will get 475. 475 minus 550 would be negative 75. So it's still 550. And finally, negative 75 minus 550 is negative 625. So it is a difference of 550. So our common second difference is 550. Okay. So I'm going in and I'm decreasing each time, so I should have negatives here. We're subtracting 550 each time. So let me do that. Okay, so now we have to come up with the equation, and since this is h and this is t, we're going to do h of t. And that's going to equal a times t squared plus b times t plus c. Okay, so now it says up here, after it says to, what does it say? Write and evaluate a function to approximate the height at which it occurs. So what we want to do is we want to use 3 different points and pick points that make it easy. When x is 10, x is 20, and x is 30. It's easy to do multiples of 10, so we'll do that. So if I used 10, 26, 90, I'll come down here for that one and put it here. And what that's going to be is h of t, 10, 2690 is 100. Okay, so h of t is going to be 26,900 for the first one. So that's our y, 26,900. That's our outcome. Is going to equal a, which a times t squared, which t squared is 10 squared or 100. So I'll just write 100a plus b times 10 or 10b plus c. Okay, so we're just substituting in our t's. So h of t in the next one is going to be 30,600. And that's going to equal 20 times a times 20 squared. 20 squared is 400. So it's going to be 400a plus b times t, t is 20, 20b plus c. And then finally, 32,100 is going to equal 30. T is 30. 30 squared is 900. 900a plus 30b plus c. So now I have three of the points substituted into our equation, and then we're going to use elimination to solve for a, b, and c. Okay, so we did this earlier in the chapter section, and now we're applying it to a real problem. And we're going to use these two first. And we're looking for a common difference, and we don't have anything that's equal. A won't cancel, B won't cancel, but C will. So if I subtract these, if I just subtract one from the other, let me do 30,600. Let me write that first. 30,600 equals 400a plus 20b plus c, and I'm going to subtract 26,900 equals 100a plus 10b plus c. So when I subtract this bottom one, I get 0, 0. This will be 29. 16, this is 7. 9 minus 6 is 3, equals 300a plus 10b, 20 minus 10, and c minus c cancel. So we eliminated the c. So now we're down to 3,700 equals 300a plus 10b. That's a b, not 106. 10b equals 3,700. Okay, so then we take we could subtract the first and third, or we could subtract the second and the third. It doesn't matter. I will do the second and the third, so I will do these two. So it's going to be, I'll do it over here, 32,100 equals 900a plus 30b plus c. And then the first one, or the second one, is 30,600 equals 400a plus 20b plus c. And when I subtract those, I like to put the second one in parentheses so I know that I'm subtracting everything. So I need to borrow from here, and that's 0, 0. 11 minus 6 is 5, 1 equals 500a plus 30 minus 20 is 10b, and the c's are gone. Okay, so now I'm going to compare these two. So I'm going to rewrite those again. I'll do this in green. So I'll take 3,700 equals 300. My pen's acting wacky. 3,700 equals 300a plus 10b. And I'm going to subtract this 1,500, but nothing's going to cancel. Yes, it is. The b's are. So you always want to make sure there's something that's going to cancel. So this is going to be 500a plus 10b. So we're subtracting this whole second equation. And we're going to get 0, 0, 2, 2 equals 300 minus 500 is negative 200a, and the b's cancel. Divide both sides by negative 200 and we find a. And this is negative. A is going to equal a positive divided by a negative is negative. These zeros cancel. 22 divided by 2 is 11. So A is negative 11. Over here, I'll write A equals negative 11, B equals, and C equals. All right, so now I'm going to take this negative 11 and substitute it in here. So I'm going to, let me switch to purple. 1,500 equals 500 times A, which is negative 11, plus 10B. And when I simplify that, I get 1,500 equals 2 zeros, 55, negative, plus 10B. Add 5,500 to both sides. This will be 0, 0, 10, carry the 1, 5, 6, 7. So I get 7,000 on the left. This cancels, and I get 10b. Divide both sides by 10. And the 10s cancel, and I get b equals. These cancel, 700. Okay, and finally, the last step is solving for C. So pick any equation. Actually, we can just go back to the original equation, right? One of these three, and solve it for C. So we take 26,900 equals 100 times A plus 10 times B plus C. So it's going to be 2,600 or 26,900 equals negative 1,100 plus 7,000 plus C. That's going to simplify to 26,900 equals 7,000 minus 1,100 is 5,900 plus C. Subtract 5,900 from both sides, and we get C equals 21,000. Okay, so these are our three values that make this system true. So we have found the equation of our quadratic. So then we say that h of t equals negative 11x squared plus 700x plus 21,000. Okay, so there is our equation that we're going to use. Now, what is the question asking for? So let me go back up. And it says after about 20.8 seconds, a passenger begins to experience a weightless environment, right? And evaluate the function to approximate the height at which this occurs. So 20.8 seconds, that's our t. So I want to find h of 20. What was it? 20.8. h of 20.8 equals negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. So h of 20.8 equals, and I'll just use my calculator to do this. So it's going to be negative, on, clear, negative 11, parentheses, 20.8 squared plus 700, parentheses, 20.8, close parentheses, plus 21,000. And I get 30,800.96. So that's approximately 30,801. So I'll do that approximation. So at approximately 30,801 feet is when the weightlessness will occur. Okay, that was a pretty cool problem.
Okay, example 4 brings the calculator into this concept of finding a quadratic regression equation. So the table shows fuel efficiencies of a vehicle at different speeds. Write a function that models the data. Use the model to approximate the optimal driving speed. Okay, so what we're going to do first is you turn your calculator on, clear your home screen, go to y equals, make sure there's nothing there, clear it, but you also want to arrow up, and you want to be up here on plot 1 where it's flashing, and you hit enter, and you arrow back down, and so now plot 1 is on. We then want to enter this data into our table, and that's under the stat button. So you press stat, and we want to edit the data. That's number 1. So you just either hit 1 or enter. And if there's data already there, you arrow up to the heading of the column, which is L2, and you hit clear. Nothing happens until you arrow down, and then it's all gone. Now arrow to the left to get into the L1 column, arrow up to the heading of L1, hit clear, arrow back down, and you start with a fresh empty L1, L2. So for starters, X is going to be L1 and Y is going to be L2. So I'm going to enter these into the calculator. So it's going to be, it's easier with a keyboard, 20. Whoops. Okay, how about over here? 2, 0. Okay, just a moment. Something's not working on my cursor. 2, 0, enter. 2, 4, enter. 3, 0, enter. 3, 6, enter. 4, 0, enter. 4, 5, enter. 5, 0, enter. 5, 6, enter. 6, 0, enter. 7, 0, enter. Okay, so I've entered all the data, and if I arrow up to the last entry, it tells me how many items are in my list, and there's 10. So I check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It matches. So I want to go to L2 and enter my data: 14.5, 17.5, 21.2, 23.7, 25.2, 25.8, again 25.8, 25.1, 24, and 19.5. Okay, enter 2 on the same row. So it didn't enter, my arrow down button failed. So let's see, it's 17.5. What happened here? 14.5, 17.5. What's my computer doing here? It's freezing. 17.5, 21.2. Okay, I should be watching when I do this. 23.7, 25.2. What's it doing? 25.2, 25.8, 25.1, 24, and 19.5. And I don't have enough. So I'm going to enter this and show you what happened here. So now I don't have enough here. So if I do any calculations, I was going to say error mismatch. So let me go back up to the top, see what happened. 14.5, 17.5, 21.2, 23.7, 25.2, 25.8. I should have twice. 25.8, 25.1, 24, and 19.5. Now I have 10 and 10 and they match up. Okay, so now I have my data entered. So let's recap. You turn your calculator on, empty home screen, go to y equals, that's empty and plot is on. Go to stat edit and that enters your data. And now we want to do a regression equation. So you do stat, arrow to the right to calculate. Now we've done linear regressions this chapter already, but now we're doing a quadratic regression, which is 5. So I'm going to press 5. And L1 is my X, L2 is my Y, frequency, leave blank, store reg EQ, and calculate. So there is my equation. So I'm going to write that down over here. So I got Y equals negative 0.141. I rounded 09. I found rounded to 1. X squared plus minus, my fault, minus B is positive, plus 1.3662, 1.3662x, and then my constant is negative 7, so it's minus 7.1441, rounding out 4 decimal places. So this is my equation of this data, quadratic best fit. Okay, so now what we need to do is store this in y equals. So you go to y equals. Now we go to the vars button right here. Press vars. We're now doing statistics, which is 5. Press 5. Arrow over to EQ. Press enter. And it put this equation in y1. It doesn't look like it, but this arrow here tells us that it's this way. And it's gone off the screen because they're showing multiple decimal places. So now that I've done that, I'm going to hit zoom instead of graph, because if we graph it, we're only at negative 10 to 10, and obviously my smallest X is 20, so it wouldn't be even on the screen. So I have to zoom statistics, which is number 9. So I press enter, and there is my data, and there is my quadratic regression best fit. Okay, so now it says use the model to approximate the optimal driving speed. So keep in mind that this is miles per hour, and how many miles you get per gallon is my Y. So you want the maximum number of miles per gallon. So you want the maximum of Y. So I want the maximum value on this arc. I want to know what the vertex is, in other words. So I'm going to go to second, calculate. See how it says calc in blue? And I want the maximum, which is number 4. So I want to be to the left of the maximum and press enter. And then I want to go to the right of the maximum, which is over here, press enter. And then it will say guess, and you hit enter. So my answer is down at the bottom. My maximum, I'm going to write it as an ordered pair. I got an X to be 48.5. 0.46. I'll round to 2 decimal places. Okay, so that's my X value. And my Y value came out to be 25.96. So what that means is if I go 48.46 miles per hour, I will get 25.96 miles per gallon, which is higher than these two values here. So it's somewhere in between. And notice 45.8 is between 45 and 50. So this is the optimal speed to get the optimum miles per gallon. Okay, that brings us to the end of chapter section 2.4. These are the exercises you need to practice to understand the concepts. Have a great day.